preparing to live stream the meeting. So hold on for a second. It's setting up your meeting for YouTube Live. Done. Redirecting to YouTube. Oh, there. To live stream the meeting. Now it's repeating what I'm saying. Hold on for a second. All right. So I got to
said you're going to have a 7-second delay or something like that, right?
Done. Redirecting to live YouTube. Oh, there.
Sounds longer than that.
Repeating what I'm saying.
We could get an interesting feedback loop voice tornado here.
Yeah, I can hear it.
Yeah, I just muted it. So when I could, now that cuts out that extra window open. So we are live, Ron. So go ahead, give us the spiel.
Hey, everybody, welcome aboard. We're at number 4. This is series 1, which I'm going to designate as, hopefully you'll agree to, the whole year that's left of 2021 as our first series, episode 4. It's the 22nd of March in the merry month here. It's our podcast of the Santa Barbara Astronomical Unit. We do them every Monday morning at 11 a.m. for an hour. You're invited to watch. We've got 6 of us all together, most of us on the board of the SBAU, which is our incredible telescope and astronomy society. Stand by, ladies and gentlemen, for a full hour of cutting-edge space stuff, developments, stars, sightings, and new scientific discoveries. We're on Mars again, as you know. My name's Baron Herron, Baron Ron Herron, proud to be the vice president. We got the president on the screen. We got the outreach guy on the screen. We got Tom Totten, our webmaster. We have Tom Whittemore, who is a past officer. I'm sure you've been an officer at some point, haven't you?
No, just newsletter.
Okay, you're the newsletter guy. That's indispensable. And a very active member, Bruce Murdoch, joins us. How are you, Bruce? Good morning.
Excellent. How are you?
Yes, this is our 4th one, and we got one more to go in a week. It'll be the 28th of March. And we're in series 1, episode 4. You can watch all these programs on YouTube. And boy, do we have a lot of stuff to talk about today. Mr. President, Jerry Wilson, welcome to spring, my friend. What's happening in the skies? Yeah.
So
keep watching.
The first thing is not on the talking point list, but there's a nova in Cassiopeia discovered a few days ago, and it's on the rise. It was discovered by a Japanese amateur astronomer on the 18th of March, Yuji Nakamura, and has been followed up with spectra from a 3.8 meter semi-telescope atop Mount Chikurinji in Japan. Sorry for my pronunciation. And it's a classic nova, which is a white dwarf star that's been bleeding material or stealing material from a neighboring star. And it just did an outburst. So it could get pretty bright. It's not a supernova, but it is in our galaxy, so it's fairly close. And as the cursor is indicating on the screen, if you can see that, go back up, Tom, to that one. You can see the 2 stars in the W of Cassiopeia between Calf and what's this other star? It's too small a thing to see.
Shadar.
Shadar, thanks. I only know two stars in there, Calf and Navi. And they're at the 2 ends of the Cassiopeia. But it's
also very near M52.
What's that?
It's also very near M52.
Oh, yeah. So you would need a star chart and look for the star that doesn't appear on your star chart. And that's the nova. So if you want to take pictures, it could get very exciting. You can take a picture every several hours or every several days, and you can see the thing flare up, and then eventually it will fade away again.
Really?
Yeah.
You couldn't see this at all before last week?
That's correct.
And
Depending on how big your telescope was.
Yeah. It's about magnitude, I think, 7.8 right now.
Okay.
That's about the limiting magnitude for our seeing conditions here.
Yeah. Well,
that will put it in.
I think we can see about magnitude 5.5 or something here.
Yeah.
Have you guys all been,
been
trying to find this in your telescopes?
Not me. It's been way too windy, and my telescope is very susceptible to the wind.
Yeah.
Is any of you doing the Mercier Marathon?
No.
So you said there's some
Group
Messier.
thing.
What?
That's kind of a group thing.
Yeah.
Well, now, I also got a posting from you, Mr. President, about something that winked out and disappeared and became
Oh
a
yeah,
black
that's on
hole.
our talking points. Let's shift to those now.
Okay.
So,
Cataclysmic variables, it says on screen.
That's just Tom wandering around.
Well, this nova that just went off, since it's one that's stealing mass from a nearby star, or it's a mate, it will keep doing this over and over again as time goes on, right?
it will, yes.
So that's a binary system that we've seen already as a one star. It looks like one star, but one of them we couldn't see and it suddenly blossomed to life. Or I don't understand that.
It wasn't naked eye visible, Ron, or this bright. It just got brighter. Whether we could see it before or not, you know, how close it was to its companion star, it doesn't matter. It's the fact that it's now just gotten brighter.
Well, I
but-
read someplace or other that it was 16th magnitude before it went nova.
What does that mean?
That means
It's
it was
very,
very,
very dim.
very faint.
Means hard to see.
Yeah,
So it was a white dwarf or a neutron star or,
White
or
dwarf.
it's a white dwarf, yeah.
white
Didn't have
dwarf.
enough mass to go neutron. But
Aren't
in
white
the
white
diagram, that Tom is showing, you see there's a distorted blob down in the lower left. That's a
Yep.
normal star that is so close to a white dwarf that it's distorted. And that point where it's within the Roche limit for that star, the gravitation is enough to pull anything that's down to that point, to pull that mass off. And it gets attracted to the white dwarf, and it settles on the surface of the white dwarf until it builds up a critical mass, and then it sets off a thermonuclear explosion. And that's
Right.
what we're seeing, is that nova bursting, or the
Right.
bright flash of that explosion. But as Bruce points out, it'll keep doing that unless the explosion's so big it blows the other star away. But it'll keep doing that over and over.
Yeah.
How close do you suppose those two stars are to
Well,
each other?
if you knew the mass, you could calculate how close they have to be for that.
Well, it would be either what, light years, light weeks, light
No,
hours.
light seconds.
I think
Light
they're
seconds.
they're less than an astronomical unit. So
Wow.
Well, Tom is highlighting up there where it's usually the size of the Earth Moon system.
So
okay,
they're spinning around each other too.
yeah,
Yes.
they're going around a common center of gravity.
Wow. Now, my understanding is a white dwarf is the remnants of a supernova explosion, isn't it? Everything else has been blasted out into space and it didn't quite make it down to
No.
black hole.
A white dwarf is not a supernova explosion is a star more massive than that. White dwarf is the end stage of a star like ours that's too low to go supernova.
Right.
Okay, but it is cannibalizing its sister star there, like black holes do.
Right.
Except with black holes, it disappears. But then again, we can now see this bloated thing. Interesting. Tom Whittemore, are you out watching these things on your scopes?
No, actually, I was gonna, when Jerry gets to his beautiful intro, looking up into the northwestern sky, I just wanted to add something when we get to that point, which you see now when you look to the northeastern sky, okay, that people might find interesting. No, I haven't. I've just been doing either binocular astronomy, Ron, or walking around the house with the dog before we go to bed and just looking up. Okay, that's kind of what I've been doing. So
I get the impression you guys don't have a lot of trees around your house, but I know you do. I do. I have trees you wouldn't believe, and therefore I don't have a scope because
No,
I'd have to drag it
we-
somewhere.
yeah, we're about 600 feet above sea level here. And we have a phenomenal view of the islands, especially the Santa Cruz Island, and basically a 0-degree horizon as you look to the south, okay? And this goes all the way to the southeast, all the way to pretty much the southwest, okay? So we can watch a lot of these things, that are rising and falling in the sky, and right now, Canopus is making a beautiful, beautiful rise and fall. Tracking Sirius, basically, actually leading Sirius. But no, I just wanted to add something when we get to the point that Jerry talks about the west, which you see after the sun goes down in the northwest, because it's just beautifully presented. So when we're there, I just like to just say,
Okay, we'll be
just
there
a
in
couple
about two different topics. The logic, okay, the logical, and yes, I'm jealous of your skies. The next thing is a logical segue. It is a supernova that is so massive that when it blew up, it didn't blow up, it imploded and became a black hole. And that's down on the star turned into black hole before Hubble's eyes.
So Hubble was watching a part of the sky and it happened. It just something went out, like turning out a light.
What's
Here
that?
it comes.
Oh yeah.
Hubble is still very, very much active. It's
limping a little right now, but it still has data that's being analyzed, and I think it's still operating, although not completely carefree.
Okay.
If Elon gets his stuff going, he's certainly capable of reaching it to do a repair. So anyway, the left picture shows the star.
wow.
And, then it went supernova, and now it's gone. And what happened was, as it exploded, it was a surface explosion, and it blew out and it blew in, and the blowing in pushed so much mass together that it became a black hole that then swallowed the whole explosion.
wow.
And oh darn. So yeah, that's it. Yeah, thanks. So this is an artist impression of that process, showing you in each stage, the start of the explosion, and then it blew in and imploded, and some of the gas got away, but most of it didn't. It became a black hole.
Wow.
So it transitioned from a supernova to a black hole.
I always thought those things took days and weeks to happen, slowly to us, to our eye.
Pretty fast when they go, but this one is not in our galaxy. It's in NGC 6946, a neighboring galaxy to ours.
Huh.
Yeah, 22 million light years away. And it
No
faded
kidding.
in an instant. That's not a real quantitative time frame, but it gives you an idea that it happened pretty quickly.
Did you say 22 million light years? That's in another galaxy then.
It is.
Yes.
Yes, it's in another galaxy.
Yeah.
We can see individual stars in other galaxies. I thought maybe Andromeda was about it for seeing anything individual.
With Hubble, we can see individual stars and galaxies up to something like 300 million light years away.
Is that right? But
They are.
they got to be the real big ones though, right? The monsters, the Betelgeuses of, wow.
Very highly luminous stars.
So let's see, we had one pop into existence and another sort of one out. They're still there, but
Yeah.
okay.
Actually, can we see stars like billions of light years away when they're supernovas, right?
Yeah.
Yes. As a
Yes.
matter of fact, that's one of our standard candles for telling how far away things are.
Mhm.
Because when one is a type 1A supernova, it has a very characteristic light curve. And so it goes to the same brightness, same absolute luminosity. And then we can measure how bright that star appears. And then we can compare that to how bright we theoretically know how bright it is. And we can figure out the distance based on the inverse square law.
Well, how often do these kind of things happen? It's kind of rare, isn't it?
It's hundreds every night.
Oh, there are that many?
It just depends how big your telescope is.
Yeah, you won't see them from your backyard.
Well, I heard, for example, or I read or obtained the information that like once every 100 years, our galaxy gets a new star. Is that a different process we're talking about there?
That's supernova. It's we think about once a century, a supernova in our galaxy, and we're overdue.
Okay, well, that's not constantly. None of us are 100 yet.
But there are trillions of galaxies, Ron.
Oh, I see. So you're looking at different galaxies.
Trillions
Interesting.
and trillions of galaxies.
And alive, so darn big.
You know, I have Stellarium open, and I'm looking at M52, which is very close to what this thing is, and it's about the same distance away from Calf is from Shetter. Now, the last two stars in Cassiopeia
Jerry's email
but it's-
mentioned there are pointer stars
but
too.
Right, but it's also, it's only 15 degrees off the horizon. So it's going to be lost in the clutter and the light pollution.
You have to catch it early.
Not for Tom.
Yeah.
Well, yeah, I have it set right now. It's at 8:51 p.m. I can go back a little bit, but
Those
I ran it
Messier,
forward. Well, see, the
It's
sun
nearly
sets at
circumpolar too,
7:10.
so you can catch it in the morning.
Oh, that's true.
Yeah, Cassiopeia will be up about 3 o'clock in the morning, I think.
Yeah.
those Messier objects are mostly novas, aren't they?
No,
No,
they're
no, no.
mostly in galaxies.
Their
a
whole
nova is a
galaxy.
temporary thing, Ron.
Say again.
I
I
went to bed
missed-
about, oh, go ahead.
A nova is a temporary thing.
Oh, okay. Things he thought were novas turn out to be
Well, he
Andromeda,
thought they were-
etc.
Well, for some of them, he thought they were comets.
That was
About
what his
star
goal
clusters?
was, to find comets.
Ah,
Because
Well,
the
that-
king would give him money for comets.
really? Well, a
Yeah.
comet moves. Comets
Chuck-
move independently of everything else. So when they come on board, they're new tracking
Chuck-
there.
Chuck, check me on this, but wasn't it Kepler who saw, he was a young boy, a nova, I think it was in Cassiopeia in 1572?
Yeah.
And that,
it was a
yeah, and that
supernova
kind of
thing.
spurred him on to, looking up at the sky and thinking about things like that.
Okay.
And then the last one visible from our galaxy or in our galaxy was Kepler's supernova 1604.
1604, okay.
So we're overdue.
Okay.
Wow.
Oh, yeah, for sure.
So now going back to the Auriga, the spring constellation,
Mhm.
one of my favorites. I've always looked at that as a shape of a house as it rises. That's how I
Yeah.
always thought it.
Yeah,
But everybody else has their own asterism line for it. So
I
anyway,
see that horseshoe.
yeah, that's the one I put that up there because that shows the house shape to it that I always recognize.
mhm.
So what you recognize and what you see in these different constellations depends on how many stars you can see in your area. So it depends on your sky clarity and things. One time I was at the dormitory level, about 9,000 feet on Mauna Kea, and there were so many stars visible at night that I could not recognize very many constellations at all. I had to have a guy help me pick out Hercules because there were so many. The pattern was lost in the crowd. But anyway,
Right, that's happened to be in southern Utah.
yeah, there's places like that in the US too. But here we are. Oh, and the other thing that confused me on Hawaii was that you can see 15 degrees more southern sky than you do. And I've learned the sky so well in my unconscious mind that it was just like a confused sky. It was very confusing to try and sort it out. But anyway, this one I like because it has several open clusters in it. And as you see down toward the bottom right of Auriga, there's a little line of M38 and M36, M37, and IC405. These are all wonderful telescope objects. And right now, with the moon past first quarter and heading toward full, the sky is getting poor to try and take images of faint fuzzies. So this is a time to look at open clusters. If you'd like to do astro imaging, you can get good star cluster pictures.
This is a big event for you every year. This Auriga. What is Auriga? Is that a star cluster or
It's a
it's not a What is it?
Constellation,
Ron. It's the chariot driver.
Yeah.
right.
okay? See, a week at the beginning of last week's podcast, I promoted the fact we were going to talk about asterisms and define it. We never did get around to it. You just mentioned it for the benefit of anybody watching us that doesn't know what an asterism is, because I just learned. This is what a wannabe constellation or something like the Big Dipper is an asterism, isn't
You
it?
can go down on the talking points I sent. You can go down to Tuesday, March 23rd, and it defines asterisms.
Okay, well, Little Dipper is
It's part of a constellation.
well, it's
It can be
part of a
constellation, or it can be any grouping of stars that catches your eye.
that
Or-
are
Well, you know,
shaped
like the teapot is a subset or of stars that are in
Sagittarius.
Sagittarius.
Or as in this example, it's tiny pieces of multiple constellations.
That's right. That's right.
Well, we have 88 constellations. Do you know how many asterisms there are?
Their asterisms are personally defined. It's whatever catches your eye. So, and you can, when you're trying to explain this or point out the sky and guide a friend who's not an amateur astronomer to something in the sky, you'll say, now you see those 3 stars there, they kind of line up, and then follow that. So you just defined an asterism as a guidepost for them.
Make
So
your
that's really
own.
what they are.
Well, you mentioned in your talking points, President Jerry, the 3 kids. Those are 3 stars.
Yeah.
And where is that an asterism?
Sort of.
It doesn't sound like it would be an old name. I don't think they called youngsters kids back in the ancient times, did they?
These are little,
The she-goat also.
these are baby goats.
Yeah.
Yeah, they're baby
It's
goats.
it's a play on the word for, Tom, could you put the triangle back up?
Wow. Comes the triangle again. That was a great table, though. I was starting to read there, and we can call that
Yeah.
up later if you want. Asterisms.
And this
Unofficial.
picture actually plays into what I want to follow up with what Jerry was talking about.
Okay, go ahead.
Okay, I was going to say, about 9 o'clock now, as I walk around the house, and the darkest part of our sky is actually in the northeast, okay, because there's really no lights over there. And what you see, of course, is now the Big Dipper asterism, okay, hanging right up on its handle, okay, and arcing to Arcturus. So you see the handle stars, the Big Dipper, basically pointing towards Arcturus, okay. And Arcturus now is coming up easily, I would say, by 9 to 9:15. We have some hills here, and so it has to clear those. The other thing I wanted to point out is everybody knows that 2 of the stars, Merak and Dubhe, point to the North Star one way. Okay, so if you look at the pointer stars pointing to the left, you get the North Star. Okay, another thing I've noticed recently, I'm sure a lot of this group here knows it. I was going to say, if you take those pointer stars and go the other way, they point exactly to the center of the lion. They point right to Leo. So that's
Wow.
kind of thing. It's kind of nice to notice stuff like that.
Okay.
Another one for Leo is if you poke a hole in the bottom of the Big Dipper, the water would run out onto the back of Leo.
Very good. Yeah.
And just hooked onto the North Star Polaris is
968 0035.
Hey, Bruce, we got noise.
Yeah,
Wow.
that's spam call. I had to silence it twice.
Let me do a little promo in the middle of our podcast, gentlemen.
Go
Even
ahead.
if you don't own a telescope, should you have an unbridled interest in this stuff, fascination of astronomy like I do, come join us. Santa Barbara Astronomical Unit may not be meeting every month at our beautiful Museum of Natural History, but we will. And meantime, we got the Monday morning podcast, 11 to noon. Just click on Contact, the tab off our webpage, SBAU.org, and join us. And then you can watch this program. I think we're live right now on YouTube, but certainly replays available. And the gentlemen here are weathering it quite nicely. It's good to see you all again. We got 2 new viewers I know of, both named Mike. Mike Hardwick is an old member, hasn't come to meetings in years, but he's rekindled now, and they should be watching us or listening, or maybe even contributing. What else you want to talk about, Mr. President or Mr. Outreach?
Ron, let me interject right here that Mike Hardwick has just put a chat comment down. He says he's been doing astrophotography and have some beautiful photos of the Rosette Nebula.
Really?
Tell him to show up on tomorrow night at 7:30 and show him to the workshop.
Yeah.
Oh,
Oh,
yeah.
that'd be great. Yeah,
Yeah.
Mike should get to the telescope workshop. That'd be great. Hopefully he's getting the emails. He must be.
Okay. Okay.
Fantastic.
Next we have Uranus, the one of the outer 2, what do they call them? Gas giants?
Yep.
Ice giants.
Ice giants, that's right.
Blue-green.
So it always looks like a blue disk to me, and sometimes with a little white cloud here and there. And The most dramatic picture I've seen of it was the 1979 passage of one of the Voyagers, I think, that took a picture of Uranus as a crescent. Very dramatic, very close up. Anyway, this is out there. It's the next one past Saturn and short of Neptune. It has six major moons. I think it has probably a zillion more.
27, it says there.
It's what?
Wow.
27.
Wow.
Okay. Short of a zillion. So this is considered an ice giant. We've talked about that before. It's believed to have a rocky core, and then the mantle, and somewhere between the mantle and the atmosphere, it's composed of ices. I guess the mantle is pretty much ice.
Why do you suppose it doesn't have the swirling color patterns like Jupiter around it? If it's all gas.
Ice doesn't do that.
Ice?
It also, Ron, it's not emitting as much heat from its formation as Jupiter is. So there's not as much roiling around in the atmosphere.
Right.
But it has a solid core, you say, but Jupiter doesn't?
Jupiter is believed to have a solid core, but it has no surface. It has no layer that you're like the Earth that you can stand on and say, this is the surface. Jupiter is believed.
Well, neither did any of those neither does Uranus for that matter, right?
No, but this one, Jupiter gets denser and denser and denser until finally it's a solid, maybe even a superconducting crystalline hydrogen core, but there's no sharp transition. It's a smoother transition. The internal structure of Uranus, as evidenced by the passage of probes that sense its gravitational field and variations, it's believed to have a solid core that is rock.
Rock.
Yep.
Well, forgive my ignorance, but is it the one that's on its side spinning?
Yes.
Yeah. Yes.
Mm-hmm.
It got
Do they know how that?
once.
Okay, there it is. Look at it. Tom, you are so awesome. We get,
It's Wikipedia for you.
One of the red dots.
yeah.
This
Oh,
is
one of
an
the red.
infrared
Yeah.
view from Hubble, and those are storms.
Yeah.
Oh, okay.
This is infrared. The pictures.
Ah,
infrared.
okay.
So you're looking at heat sources. This
Really?
it does have internal heat, but it's not anywhere near as dramatic or dynamic as Jupiter is.
Well, I've heard the breezes, if you want to call it that, on either Uranus or Neptune go 1,000, 1,200 miles an hour.
That's
Yeah, very
Neptune.
high.
Yeah.
You would think that alone would produce heat just from friction, wouldn't you?
It does. Yeah.
Okay. And all those Shakespearean names given to the bigger, I guess, moons. But the guy's name is Herschel. He discovered it, what, a couple hundred years ago, right?
1781, I think.
1781, that's right.
And it was discovered
Mozart time.
based on mathematical predictions.
Well, not Uranus.
Oh, is that
That's
your?
Neptune.
Neptune. Yeah.
This is his
Oh, yeah,
7-inch
you're right,
scope
you're
that he discovered Uranus with while he was in Bath. And they have a replica of it at the Herschel Museum there.
Yeah.
And they also have the actual one, I think, at the Science Museum in London. And it's just a little like a 7-inch, 6 or 7-inch Newtonian.
Yeah.
Really?
So it was 8, but yeah. I looked at that when I was a kid and I thought, wow, I could make one of those.
Yeah.
And here we go.
What is the little dinky device attached at the top on the side? Do you
Well, one
sight
of it's
through
the eyepiece and the other is the finder.
Oh, okay. And Galileo didn't have one this good, did he? He was a century or two before, I think, wasn't he?
And this is a reflector, but it's
Yeah.
not with glass. It's a reflector made with speculum metal. So it's like tin and some other metal, tin and copper.
Copper.
Okay, so they got a parabola-shaped mirror in the back end of that sucker.
Sort of, yeah. They wasn't, the ways of making a parabola weren't perfected, so it was really an art as to whether you got a good mirror or not.
Well, this one is long. It's probably an F10.
It's a
And at
7
that
foot.
point, the
7 foot
difference
focal
between
length.
a parabola and a sphere is negligible, so you didn't have to know how to do a parabola.
Right, right.
That's why they made them so long.
But how do
I
you,
don't know. Oh, I don't know how to share photographs on my little tablet here, but on the 8th of October, 2014, we were up at Westmont, and there was a lunar eclipse. And it was just happenstance that, and I was photographing it through my C8, that at almost the blood moon, my picture's got Uranus in it.
Really?
And I didn't find, oh yeah, it's blue. It's neat. I would love to put this up, but I don't know how to share this.
Tom has to let you share.
Well,
Well, no, I don't know on my tablet how I get
Oh.
out of the Fire Astro, the Zoom applet and get into my, I don't know how to bring it in from the, where
Okay.
it's stored on my tablet, but I don't know how to get it shared.
At the Herschel Museum in Bath, which is where he discovered Uranus, just out on the street with this thing,
Mhm.
in the backyard, they used to, he would melt the metal, the speculum metal, and actually cast his mirrors. And they used large piles of horse manure as the casting block, that they carved out the shape into. And you had to be careful because when you poured the molten metal into it, if there was still too much moisture left, you got an explosion. Steam, basically. And what you can see is in the back patio where he was doing this, there's still cracks in the flagstones from the explosion when he was trying to cast one of these mirrors.
you suppose this thing is in the Smithsonian or European version?
It's in the Science Museum in London, and there's also a replica in Bath.
Yeah.
I'll be darned.
You
According
mentioned
to
also Galileo's telescopes. Back in the 1600s, they didn't make mirrors. They made lenses, of course, and the lenses were not made with any kind of testing or knowledge about how to test their quality. So they just made curved pieces of glass, and then they went through and they found those that worked and threw away those that didn't. And if they found one that worked well, they started diaphragming it down in aperture to improve its quality until they got an image that was fairly acceptable. But they were very rudimentary telescopes, nothing like what you see through today for that size.
Right.
And Herschel also worked with very large magnifications. And the way he made his eyepieces was by flinging molten glass into a bucket of water. And he would get these spherical shapes, and then he would try them out for his lenses.
Yeah.
You're kidding. How would he know? How would he have known when he first spotted this little blob that it wasn't a star? Is it moving different from the background?
Yes.
It moved. Background didn't move.
He thought it was
Okay.
a comet. And he wanted to call it Sidereal Georgium or something. King George's star.
But how would he know, for example, that it's not closer than Jupiter or Saturn or even Mars? How did he know it was the seventh?
Around the sun.
Oh, it's how slow it moves in the orbit, I guess.
Yeah.
There's
And-
my picture.
Jerry Wilson's notes mentions kind of a flat star-like. It's, not really bright like a star. When you see it this week, I think Wednesday is the anniversary, right? But Bruce just said he saw it as blue. Do you guys see it as blue from this far
Yeah.
away? And you're,
The picture you just saw was blue.
I know
Oh,
it's
here, I'll
blue,
put it
but
all. You're just looking at my computer screen with my tablet. I don't know what I'm looking at.
It looks more
Which one's
greenish to me.
Jupiter? I mean, which one's Uranus?
This
It's down here.
that's not blue.
It is to me in my eyes here.
Yeah.
This is a poor. Come on, turn right side up. Um,
Wow, how do you do that?
You're up, yeah.
There you go. Otherwise, you're going to have to hang from your
Okay.
legs. Talk to us.
Okay.
Wow. Do you
no,
teach
thing's
this
got-
at
this
Westmont?
thing's
Do
got
you go into
accelerometers
the,
in it, so-
yeah, well, welcome aboard, gentlemen. I know we're all waiting to go back someday, maybe later this year, but I was just curious about Tom Whittemore, who taught, I think, electronics and some astronomy in a lab, right, at Westmont before being
Right, so
furloughed?
astrophysics, yeah, a number of physics courses. As far as the planets go, just to study Keplerian, orbits, do the mathematics behind that. Other than that, we've seen Uranus and Neptune really beautifully through that 8-incher at Westmont. And when it's up in the sky in good position, boy, I show it to the public. Okay.
Really?
But of course, we haven't met. Ken pointed this out to me the other day. We haven't met for an outreach at Westmont since February of last year. you know, so I really miss showing the folks. And I'm sure Chuck does too, you know,
Come on.
and Jerry showing the
Well
folks
set
the
up.
stuff, you know.
Do we know, gentlemen, who we're going to be dealing with at the museum now that Javier, our connection to astronomy, is retired?
Are we dealing with Charlotte?
Charlotte is kind of our liaison right now, but apparently in the future it'll be someone else, I think.
Okay.
Do you
We're all
recall
going
when
through
the
a transition, I guess.
Yeah.
Let me do a quick plug here. If you do not receive our Santa Barbara Astro Unit newsletter, it goes out each month from our editor, Tom Whittemore. Please just visit the club's webpage, as everything else is on there, sbau.org. And Tom, I believe you're saving all these podcasts, are we not?
Yes, well, of course, this is live, of course, the podcast, but the newsletters are saved. The newsletter is saved at the website as well. So
This
Yeah,
will be
Paul
number
Wynn
4.
started doing that, you know, archiving those back to 2007, if I remember right. So
Yeah.
they're probably still up, huh, Tom?
which one? Yeah. Oh, yeah.
Oh,
yeah.
the archives of all the newsletters going back to 2007.
I've got them
Paul
going
Wynn
back to
used to
like
save them.
99.
Oh, they do. I didn't know that. Okay.
Well, I've got them going that old.
Oh, okay.
I don't know if I gave them to Paul, but I don't think he put them all up.
Yeah.
You know what you
I
should
remember
do?
2007 because a good friend of mine died that year, Tom Mudd, and I wrote a piece on it. And you know, every now and then I go out and I can look at it again to see what I said about him.
And
Well, what did
speaking of
President Jerry write about for the April edition? Do you know?
Jerry,
I haven't read
Jerry's
it.
probably going to send me something. I hope. Okay,
Yeah. Next few days.
that's
So-
fine. That's right, Jerry.
Is
Speaking
there
of
any
the- of
is
the-
there any topic you'd like to hear about?
Perseverance.
For me, I'd love to hear how you talk about the night sky for people who just like to look up, you know,
Okay, I'll do that.
you know,
I'll try
who may
that.
not have a telescope or even a pair of binoculars. So
Well,
going back to the
we've all
museum
been following Perseverance. Percy, the rover on Mars, is they're about to set that drone free, are they not, in the next week or two?
Yes. Going back to the museum people, I just got an email from a person who used to be Javier's assistant, Samantha Thompson. And I think old timers will remember her, but she was working on a PhD in history of astronomy. And she went from us to Lowell Observatory in Flagstaff. And then I got an email from her. She is now the curator of astronomy at the National Air and Space Museum in Washington, D.C.
Oh my gosh! Wow.
No kidding. Congratulations. Should send her a
Watching
notice.
our show.
She did say
Yeah.
she might be interested in doing some collaboration with us on outreach. So we'll see what
Excellent,
happens.
Excellent.
Oh, how neat! How neat! Yeah, I remember her real well. Yeah.
Yeah, she's a nice.
Does
girl.
anybody know how those girls, Girl Scouts that came talking up to about starting their own little astronomy club for teenagers is doing?
Well, they have their own astronomy club. They even have an observatory that they've just set up at Camp Arnaz near Ojai.
Really?
Okay.
Well, Thatcher School over there has an observatory back up
That's
and
way
running.
up in the Ojai Valley. This is more down toward Ventura.
Okay.
So they're meeting with their masks on, I guess.
Yeah.
Okay.
So anyway, this Friday night, let's see, this Friday at midnight, Venus is in Superior Conjunction.
Okay.
Chuck, the Baron, do you remember what that means?
Night or morning? Which is it?
A superior conjunction means you can't see it. It's on
You
exactly
can't see
the other
it.
side of the sun from us.
It's buried below the horizon somehow.
No, it's right behind the sun.
Behind the sun.
Oh,
Yeah.
behind the sun.
That's superior conjunction. Inferior conjunction is that it's between the sun and us.
Wow. So it went down to a little dinky crescent, didn't it?
Well,
Well,
that's
no,
when it's in
it's a
inferior conjunction.
At superior conjunction, it's full. It's when it's close to us. At inferior conjunction, it's a big crescent.
That's
Yes.
true. I just realized you're absolutely right. It's on the other side from us.
And it's
Mhm.
shifting now from being in the morning star to being in the evenings, to being in the evening star.
How often does that happen? About twice our year, doesn't it? It goes twice the number of orbits we do for our year. It gets 2 or 3 years, doesn't it?
It's something like that. I mean, it's got a 9-month orbit, but then you got to account for our motion too. So
Yeah.
I don't remember what the periodicity is there.
Wow.
And as you pointed out earlier, this month's full moon, which will be on Sunday coming up, is the worm moon.
Why? What's the worm going to do with it?
Springtime, the worms are coming up.
Oh. Is it
Saturday's Passover.
and it's too early to be a blue moon. That would have to wait a day or two. It would get 2 in the month of April, I guess.
Yeah,
Right.
and also that phase, defines Easter, right? First Sunday after the first full moon after the vernal equinox. So we just had the vernal equinox. Now we're going to
I
get the
never
full.
remember that.
Yeah. Now you get Easter.
Yeah.
On
Okay.
the 4th of April.
My impression, guys, is getting to be that you hate that damn moon. You just as soon it not get as full as it does. Every 30 days, you got to turn your telescopes off of what you're watching already because it's obliterated, right? By a
Well,
bright
no,
spot.
there's the planets and there's of course the moon too. And you notice that the topics we talk about are more faint fuzzy topics around the new moon, and they're more planetary stuff around the full moon. So we go that way. I personally right now I go back and forth, but right now I like the period between between last quarter and first quarter, which is the dark 2 weeks of the month, because that way the moon doesn't interfere with taking pictures.
The nice thing about occultations is you don't have to worry that much about the moon.
That's right.
But
And it
can we
makes
talk
people-
about the moon for a second? There's a program called Artemis. We're going to go there within the next couple of years, right?
Yeah.
Via Elon. And yeah, those are the pictures I was going to refer to. They've actually seen some of the landers. There's on the backside, that's the China one pictured.
Oh yeah, going down. That's related to Artemis only because they're going to the moon. But let's see where that is. Yeah, this is on the backside of the moon. This is the Lunar Reconnaissance Orbiter, which has been up there about 15 years, if I remember right. And it takes pictures of it's mapped about 92 or 95% of the moon's surface in high detail. And here it shows 2 pictures of the China's rover, which is on the back side of the moon, the Chang'e 4 lander and its little rover U-22, where they were observed by the reconnaissance orbiter. And between the 2 pictures, I don't have a date for the left one, but you can see that the rover has moved away from the lander.
Oh yeah.
Pictures.
You can
Really?
also see shadows cast. The shadows cast too.
Yeah, nice shadow.
Long shadows, yeah.
Yeah, it just tells you that the moon is illuminated half time, all the time.
Yeah. So this is the dark side of the moon, stating it wrongly. It takes them a long time to move on the surface because they have to keep moving that arrow along with them.
Yeah.
That's pretty good.
But we couldn't see them before. How in the world do they suddenly zero in from that far up?
Well, this Mars Reconnaissance Orbiter is only about 100 kilometers up above the moon.
Oh, it is.
Yeah, it's fairly close.
Are we talking ours or China's? China's got an orbiter, do they not? They'd have to.
Yeah, China has a Mars orbiter. No, they have a Mars lander, just hasn't landed yet.
Well, I'm
They
talking
have-
about if
they have
they're
an
going to
orbiter.
get, how are they going to get stuff back from the far side of the moon, China, if they don't have an orbiter to relay it to us?
Yeah, they do have a relay orbiter.
Oh, okay. So we're starting to put pollution around moon after pretty much dirtying up our planets.
Yeah, we're very
Next year.
generous with that stuff.
Okay.
So that's one of the things that, what's his name? Neil deGrasse Tyson
Mhm.
had said about colonizing Mars is that in order to terraform it, all we need to really do is warm the planet up. And certainly among the things we do best is how to warm up a planet. Then they
Well,
would expect
They already got the carbon dioxide though.
Yeah, but
But just
Yeah.
not
apparently
enough.
there's a lot of water, an ocean worth of water just below the surface of Mars. If you heat it up, it'll come up.
Well, if you ever saw the Total Recall movie starring Arnold Schwarzenegger, they did it in about 10 minutes at the end of the movie.
Yeah.
Yeah, that was pretty funny. If they did it
Stupid
that
as I-
fast, there would be storms like you wouldn't believe. It'd be decades before the winds died away. That
Well,
movie was so poor.
Supposedly the planet Mercury, which we've orbited and checked out close up, is similar to our moon. If we were to land somehow on Mercury, what would be the difference? Just hotter?
Quite a bit hotter and a lot more iron, a lot denser.
Yeah. It's only superficially like our moon because of all the cratering on it and stuff. One way to think of it, a little oversimplifying, is that Mercury is more like the core of a planet and the moon is more like the crust of a planet.
Oh. And the thing that surprises me about Mars and the moon and Mercury, I guess, is all that dust. It's all kicked up by incoming asteroids and comets colliding.
Yeah.
But on Mars, they also, what?
It's pretty much created by those impacts.
And
Wow.
just heating and cooling. It goes through, you know, if you don't have an atmosphere to blanket you, you go through such severe heating and cooling that rocks expand and contract and flake.
Okay. And there are some good sized asteroids that are covered with, if not sand and dust, they're covered with millions of rocks, aren't they? Littler rocks.
Or they're just piles of rocks.
I guess it sucks in all the other little asteroids to its minimum gravity. Fascinating stuff. So did we cover every night this week? Venus on Saturday, the conjunction, midnight, you say, right?
I think we covered everything sufficiently.
All right, on a full moon.
Yeah, so let's go
And-
down, as long as we're looking at the moon, let's just take two quick shots at the previous things. Things you can't see from Earth, but one is the Apollo 11 landing site, which shows the lunar module, a camera that was set there to take pictures of the lunar module, the reascent stage, discarded cover, and
Wow.
I forgot what LRR means and PSEP. Maybe you have a memory of that. But you can see tracks on the moon where they went between these different things. They didn't have a rover on Apollo 11. They walked.
That's what that line in the, yeah, that's going on
Yeah,
right over to
that's
the,
a footpath. They're just following animal tracks.
that's it.
So that's a very high resolution from the Lunar Reconnaissance Orbiter. We have a reconnaissance orbiter about Mars too.
And there's,
So we are building up infrastructure around both the moon and Mars. And one of the things around the moon is going to be the Gateway station. It's a mini version of the ISS, and it'll orbit the moon, be a refueling station, a stop-off station for landers to go from the Gateway down to the lunar surface, and other craft to dock with it coming from Earth. So it's an intermediate stage. It's not just everything all the way, one long logistics line from the Earth. Here we see the Apollo 12 and the Surveyor 3 landing site. The descent stage is shown. The ascent stage is already taken off, so it's missing. And then there's the Surveyor. You can see an arrow pointing to Surveyor 3, which landed on the side of it was a pre-Apollo robotic station that would sample the surface and take pictures. It did not rove around. And but the astronauts went over to it, walked over to it, and cut off a number of cables and samples to bring back to Earth to see how those different materials responded to the vacuum and proton bombardment from the sun over the years that the Surveyor had been there.
Wow.
So they were checking it. They brought it back. Some of the parts came back to a lab I was working near in that Hughes Aircraft Company at the time, since they had built a camera for it. So
They also found bacterial spores on it that were still viable.
live.
yeah,
Wow.
they're finding that on the ISS too, on both the inside and the outside of the ISS. And they've taken samples. I guess there's 3 or 4 different types of bacteria, and they're being analyzed for their ability to survive in space.
What do they eat?
Don't know. Big question. Maybe they hold their breath for a long time.
They also
And you-
found some small insects there. Did you know that, Jerry?
Somewhat.
Small insects
No, I haven't
nearby.
heard
They called them lunatics.
that. Cancel that, folks.
Yeah, well, that was my question last week. How do we know the Perseverance is totally clean? I guess, if they cleaned it and then they put it on the rocket, and the putting on the rocket time, they might be able to pick up some more stowaways, don't you think? Some more riders?
They try to clean it as best they can, but it's impossible to be 100% clean in my view.
So
We
if
always risk pollution.
well, as long as we're there on Perseverance, what do you know about the Ingenuity? $87 million for that drone. Can you believe that, for 4 pounds and 2 rotors? And next week, I guess they're going to send it up, aren't they?
Well, next week they're going to announce their plans for a timeline. They've already identified now where they want it to fly from and to. They're planning to give it a first flight, I guess, the first week of April, which is a week after this.
Yeah. And it
So-
has 2 cameras on it. Do you happen to know what the difference is, or is it a stereoscopic?
One is color and one is black and white.
One is color and one is what?
Black and white.
Black and white.
Why would
The
they have
black and white is more sensitive.
I don't know.
Oh,
Black and white is more sensitive and it's a higher resolution because you don't have a Bayer mask on as you do on the color, which drops your resolution by a factor of 2.
I wonder
Yeah,
if the
they're not-
same contractor made the little helicopters, made the $640 toilet seats.
It wasn't done by a contractor. It was done at NASA JPL.
Yeah, but you said, I forgot how many $1 million to make this little helicopter.
That's probably
87.
mostly
Yeah.
spent in testing it, because they had to test it in a vacuum type environment.
Oh yeah, one of the big spheres.
So
But it's-
I would suspect whenever NASA makes anything, there is a Christmas tree of subcontracts. And they, at each level, because we do this, and when I was at SBRC and other contractors do it too. You build something, you build a part, like we would build a camera and we write SBRC on it. And then when we'd send it up to the next level of system engineers or integration, they would peel the SBRC label off and they put their label on it and put it together with their thing and they send it up. And so that's why people put a label in there that cannot be removed. For example, we would etch SBRC into our chips in one corner where you could only read it with a microscope, but it couldn't be taken off. And JPL did that with putting in the wheels, they put in Morse code of JPL, so that everybody would know where the wheel came from.
Although they had to stop doing that because the wheels wore out too early. So
That's right, they did. It backfired on them. And so this time someone put some codes in the parachute, but this time they weren't the label code of who made it. But that's just typical of how these subcontracts flow down and then the parts flow back up. And yes, NASA was the prime contractor and the top integrator, but all the components were generally made where the components are specialized. That's what that company does best. For a long time, Raytheon and Hughes are traditional component suppliers. Raytheon wanted to be an integration house, but they had all the component suppliers locked up, and so there was no way to get any focal plane that was better. So they're kind of stuck in that position.
Huh. Do you
So-
suppose, Mr. President, any of that stuff is made out here in Goleta anymore?
Anymore, I don't know. I retired from Raytheon in 2006, and we sort of were taking away, when Raytheon bought this part of Hughes, they had a duplicate. We were in the Civil Space Division here in Goleta. Raytheon had a Civil Space Division and laboratory and everything down in El Segundo too. So there were duplicate facilities, with their LA one being much larger. And about the time I was retiring, we exceeded the ability to test and verify that we met spec. So they had to resupply, rebuild the test labs with new equipment, and it was just an astronomical bill. So they weren't going to do it in 2 places. So they moved it down to LA. And so most of that stuff has gone down there. The components for making the actual crystals that are on the chip, that has been done up here, and it's a major stake in the ground. There's a saying in aerospace about technologies: if you move it, you lose it. So we developed it at great expense to make Mercad telluride infrared detectors and other things up here, and nobody else makes it as good as we do. There'll be a flood of competing hate mail coming in now because I said that. But so that's still grown here at the Raytheon Vision System. There's no way around that. So it's a very low component level.
Well, just like you can get tours of JPL and the Wilson Observatory. Do you suppose out there at those R&Ds, do they give tours to the public? Can you put a group together and see their stuff?
No. It just looks like a bunch of offices all surrounding a central laboratory. And the central laboratory is one of there's only, I don't know, 10 or 100 clean rooms of that level in the world. And they're not going to let anyone in there unless they're trained. You think wearing a mask for COVID is tough. You're going in one of those labs, you have to wear a bunny suit in there, and you can't wear you can't wear gold, anything gold, because the gold atoms will poison the superconductor components you're growing. So,
What happens if you have gold in your teeth?
Well, you see what's on the screen right now, that thruster thing that slowed it down, slowed Perseverance at the very end. Is there a twin of that works that they tested here on Earth? You suppose? The one that's on the screen right now, whatever that thing is, that with the 4 blasting, the crane.
Guy crane.
Is that had to be tested somewhere? They probably wouldn't be able to find a vacuum room big enough to test it, so they'd have to do it out in the desert or Death Valley. And
we have a lot more experience with stuff like that, though, from landing the original landers on Mars and from landing on the moon. So that's a little.
I'm sure they tested that.
Yeah.
Well, I'm sure, but how would they know? It's not the same atmosphere.
The atmosphere is not a big component here.
Yeah, the atmosphere is not a big component. Gravity is, and what they can do is partially suspend it on cables.
Yeah.
To mimic gravity.
I don't know if you remember this, but when they were training the pilots to land the lunar module on the moon, they made a big pipe frame chair to sit in, and they had the 4 retro rockets like this, and the pilot sat in the middle, and he would practice lifting off on the rocket thrust and then moving over and then setting down. And so that's how they tested or trained the pilot to do that landing maneuver.
Wow.
It's pretty well understood, unless one of the rockets fails or something, it's going to work.
But
I'm sure they tested each component. After the
It looks like they have 2 rockets on each corner.
Yeah,
it's redundant.
Redundancy, yeah. After the Hubble fiasco, there's no way anything's going in orbit that hasn't been tested completely.
I think a picture that you sent us that I got from you, Jerry, showed the undercarriage of the Perseverance, and what looks like an oil pan off a Hummer is sitting there on the same. Did you see that? I didn't see any drone.
Tom, can you go to that photo?
Ron, that's the cover that was on the drone. The drone is still attached to the bottom of Percy.
Yeah,
it is.
This is the one that's
there it is.
Percy with the helicopter below it. That is that's an artist's conception. There is an actual picture of it that shows it. I sent it in a later email. That's the one. If you can show that, Tom.
I can find that. Give me a second.
Yeah, it looks like an oil pan fell off of the rover.
I think I have it.
And it makes you wonder, why didn't they just set it on top of the rover and let it just take off from above rather than laying it down and backing off? Well, there's got to be a reason for it.
There's a lot of terrain up on top that's used for instruments and for testing and for parachute attachment and stuff like that.
Okay, that makes sense.
It would get crushed when it gets all folded up too. For a
there
launch.
it is.
Yeah,
Look at that.
there's an actual picture, and you can see the cover for the helicopter laying on the ground there while
Yep.
they get the oil change. And then laying sideways and all folded up, this silver aluminum foil covered square to the left, that's the body of the helicopter. And
Wow.
then one of the rotors.
One of the rotors. Welcome to Jiffy Lube. Uh-oh. Are you back?
Everything's all folded up.
Yeah, you can see
Interesting.
The
We're
legs.
gonna have to end it on that, gentlemen, and do another one next week. It's nice to meet you once a week and 2 hours later, but we get it mostly covered. And
I think we
doggone,
covered
it's
everything for the first time.
yeah. Can't wait for us all to get together on a regular basis. Meantime,
Yeah.
Tom, thank you for running that web and SBAU.org. Is that where you go to get everything, right? And
Yes.
we'll do number 5 next week. Give our love to your wives, and you guys stay safe. Wear that mask. All right.
All right.
That's it
Okay.
for podcast number 4.
Thanks,
We'll